Oh, here we go. We're up. Um, Here we are this week in Cassandra on Planet Cassandra. Today we've got Patrick McFadden and Jeff Jersa from CrowdStrike. We're going to be talking about the news, and then we're going to be talking about some stuff that Jeff has been working on over the last few months. That's pretty interesting. Before we get going, though, Patrick, we've got some big news, don't we?
Yeah, we do, don't we? Some really big news.
He's like,
Which big
no.
news would that be? Would that have to do with anything where we're all going to be in one place?
I think it does, yes.
I love it when the family gets together. This is great.
Yeah.
And we're talking about the big family, aren't we?
Mm-hmm. It's everyone. You know?
Everyone's invited. Cassandra Summit. So good. This is my favorite time of year. Actually, it is my favorite time of year is when we do Cassandra Summit, because it is a huge family reunion. And what's nice is that I don't have to fly all around the world. Everyone flies to my hometown.
It is a nice change of pace.
It is a nice change of pace. So Cassandra Summit is live today, cassandrasummit.org. You can register now. Watch Twitter for discount codes. Don't give yours yet. But watch Twitter. John and I, Dwi. There's a few others you might be in your Twitter feed that will be giving out discount codes. But it is open today. And I will tell you this. You need to register early because we're looking at the sizes of this year, and I think that the community has spoken loud and clear, including myself. We do not want a massive 10,000 person summit. They're just not useful anymore. So we're gonna keep it about the same size as last year. It doesn't mean the demand is lower. That means that now it's going to be a little tighter. So if you're waiting till the last second, you may be unhappy.
Yeah, I think we've been to some conferences where people are just kind of wandering around without any real, enthusiasm of being there. It's kind of just like a way to spend a day that's not in your office chair. That's definitely not the point of this summit, right? Like, if you're a Cassandra user, you want to learn, like, you want to take this stuff seriously and meet some really passionate people. Like, that's the way to go. Like, I've mentioned on here like a couple times that I learned a ton at my first summit in Fort Mason, right? And that's actually where Patrick. That's where we met for the first time in person.
That's right.
And
who is this crazy?
Yeah, it's like, who is this guy? And it's awesome. Like, you get a lot of people, and you get a lot of enthusiasm. You get a ton of energy around, this database and kind of the related ecosystem. And there's a lot of cool stuff, and you end up having a lot of side conversations. I've had conversations where, like, all of a sudden we pull out a whiteboard and we start talking about algorithms and data modeling, and all of a sudden we're like, oh, we can actually do hyperlog in Cassandra, and it's like, that's pretty cool. So that's the stuff I love.
Jeff was one of those people in the community that after the summit was like, keep it this size. Jeff, you can speak for yourself, but
it's one of my favorite events. We go and we spent a lot of time. We talked to people like Levy at the Weather Channel, and we got a lot of value out of just actually meeting people and talking about some use cases. And we talked to Levy about some secondary index use cases that we hadn't thought about. And we talked to Christos at Netflix about some disk performance things. Like our talk last year was about EBS, using Cassandra on EBS.
Yep.
And they obviously have thousands of Cassandra nodes at AWS. So we demonstrated some cost savings, and they were really interested in it. So there's a lot of bidirectional knowledge flow that happens that you just don't have an opportunity to talk about in any other place.
Yeah.
So one of the things we're planning on doing this year, and I'm involved in a lot of the planning, and I'm trying to take that feedback and turn it into something really useful, and that is trying to encourage more collaboration. Instead of just making it a drill, like a slog of sessions one after the other, and you're just running from one thing to the other, gap them out a little bit, create spaces for people to have those conversations, because you're spending the money to be there. It's a bunch of like-minded people. You should have the time to do it.
Yep. Oh, and CFP is open.
Oh, yeah. So if you're interested in not just listening, if you want to be on the other side of the podium, the cfp.cassandrasummit.org, wide open, bring it in. And if you think you don't have an interesting use case, think again. You probably do.
Yeah, and hit us up too. We're available. We can. Uh, I think it's a case of a lot of people are like, oh, the thing that I'm working on, like nobody's going to be interested. But it turns out that a lot of people have the same problems. And if you've solved something that was bothering you for a little while, it's a really cool way to address it and to help people learn. And that's what most of these talks are. It's like I ran into a problem and I couldn't figure something out, and now I have a really cool solution. And that's actually what we're going to be talking to you about, Jeff, in a little bit. But before we get to that, I think let's just rein it in just a little bit, because we do have some other things that I wanted to touch on first, because we'll get carried away if we start talking about time window compaction right away. So before we get going, I just wanted to talk about a new change to CQL that's coming in JIRA 7017. This is pretty cool. So there's a common data model where people have, let's say, like leaderboards, and effectively what you have is a partition key where it's like the game and then a bunch of scores and people, and frequently you may want to say, like, I want to get the top 10 players in each game. Well, 7017 is about adding a per partition limit clause, so you're effectively kind of doing like a full table scan, but only taking the head of a partition. So this is pretty cool. Patrick, I know that we've talked a bunch of times about data models that involve leaderboards and kind of how Cassandra is used in gaming. And this is I think a pretty cool feature. Like getting top N from within subgroups or from within partitions is really, really useful.
Well, that points out one of the I think as a 3.0, 3.x is moving forward. This is such a big deal as usability. The changes that are happening in CQL are making it more usable.
Yeah.
I think that's if you have three corners for a good database, it's going to be the usability is one of those three, and then performance, and then node density is another. But the usability has to be critical, and it's so hard because there's just a million things to do. But we're going in the right direction, I think.
Yeah, I mean, because before this, one of the interesting parts about this particular issue is before this, you would have to keep track of every game in some table, right? You'd have to have a list of all your partition keys, and then you'd have to go out and query them all at once. So this is usually not like I mean, we're using a leaderboard case. There's usually not a ton of data associated with that, but I think with any of these types of queries, you find like top N in a partition is very it's widely needed, right? Like, if I have a billion partition keys, going out and finding all of them first and then doing a billion queries, that's a ton of overhead, and it's kind of pointless. And so this will definitely be really, really cool. I think we'll see some fun data models come out of this. The next thing that we wanted to talk about was, and this is pretty cool, from Pearson. They just open sourced this, Cassandra. And we were pumped to see this the other day.
It's like one of those things that just comes out of nowhere. Yeah. Like, where did that come from?
Yeah, I had no clue this was coming. Cassandra is effectively a REST based document database built on top of Cassandra. So, like, the things that people like about Mongo, Pearson's like, whatever, we'll just use Cassandra instead, because like that query flexibility, like the flexibility of Mongo and having documents is cool, but they don't really seem to like the baggage.
I would really love to get someone from Pearson on here to talk about it, because I'd like to know why they built it. I want to know some motivations, because I mean, this kind of stuff usually has a great story.
Yeah. This is pretty cool.
It's also beautiful that they open sourced it. Like it would have been understandable if they kept it internal and used it, but it's awesome they actually give it back to the community so that everyone else can use it.
Yeah, absolutely. I mean, the fact that they decided to well, and there, like I said, there's probably a story, and I've worked with a lot of large companies that have struggled with, do we put this into open source? And I do a talk at OzCon on this, and I hate to see when people put something in open source when it's just like they put that box of junk on the curb and put free on it. It's like they're just throwing stuff over the wall. Yeah. But this seems like they're way more motivated to share, and then also participate, and that's awesome.
Yep. And it's not their business. So I think a lot of people are afraid to open source things, but
Right.
that thing isn't what's making them money, right? Like Pearson's not a database company. There's no reason for them to say like we're not going to open source this. Like it's our secret sauce is our database. It's like, well, probably not. I think it's pretty cool, and they're actually they're pretty cutting edge. I mean, it's not just this, but they were Titan users before anybody even heard of Titan. I think they were like the first one. I think I may have been the second one. They're like those guys are willing to try new things, and I think it's pretty cool. So yeah, it's definitely one of those projects that everybody.
And I like the little nod to the Sandra. We had Twist Sandra and Solandra.
Yep.
There was a lot of Sandras out there. Now we have Sandra.
Yep.
This is great.
Yeah. Oh, and I think what's really interesting about this is this reminded me, and they even give a little, credit to the user grid project, which kind of ties in directly to work that Nate McCall did. So Nate McCall,
user grid,
PMC.
Yeah.
He did some work a while ago when he was at Apogee, and there's a video out there somewhere where he's kind of showing off like, oh, we wanted to see if we could make Mongo wire protocol work with Cassandra, and there it goes. So this is a pretty cool evolution of that, and I definitely want to see how far they take this, because I think it'd be pretty cool to just be like, yeah, you have a super flexible document database on top of Cassandra. So, all right. So I've been ranting now for a little while about document databases. The meat of the matter. Why we have Jeff on here. Jeff, so you wrote something called time window compaction, which is pretty cool. Like I've taken a look at this. Like it's really well written code, and I know that you guys are using this in production at pretty big scale, right? What can you give us about your cluster size and how you're using it?
Yeah. So we have a very large time series cluster. It's on the order of a couple hundred nodes, and it's on the order of about 700 terabytes of actual data. So
Okay.
The available disk is considerably higher than that, but about 700 terabytes of live data, and it's all TTL and it all expires. So one of our kind of ongoing concerns is being able to expire that efficiently and make sure that we don't keep extra data on disk that we don't need. So if we use something like size tier, if we use level, there's no real guarantee when data will be dropped, when tombstones will be actually cleaned up.
Mm-hmm.
So we wanted something that was very easy to understand and very easy to reason about. So we explicitly made a new compaction strategy that, instead of grouping SS tables by size or by partition keys, would group them into something that was the easiest thing we could think about, which was basically say, I want one SS table per day, or I want one SS table per week, or I want one SS table for every 2 minutes of data. And that's all it does. It's like the simplest possible thing to think about. And basically, as you feed data in, it does kind of size-tiered compaction. And as soon as it hits that window, it kind of joins them all. Very, very aggressively, very quickly. Smallest first, and it gives us kind of a very easy to think about, a very easy to reason about compaction strategy that gives us really good performance.
Nice, very cool. So what are you guys doing with that over there at CrowdStrike?
So I was gonna say, we should mention the name of where you work, because you said we. Who's the we here? CrowdStrike. Thank you. And by the way, just a quick little plug for CrowdStrike. You guys are awesome in community. Plenty of content out there from CrowdStrike on cool Cassandra topics, but continue.
Yeah, it's a fascinating company. I've been here just about a year. But what they did is they built a kernel level sensor that tracks things like file handles and process creation and thread injection and network connections. And what we do is we use it to track adversaries. So we use it to track malicious actors, and you can think of it almost like antivirus on steroids. But it's more than that. If someone opens an email and saves an attachment, and that attachment, creates a file that gets executed, makes a connection to some foreign country, any of those individual steps may not be a big deal. But when you look at it as a whole, that whole situation we can kind of understand is malicious. So we keep kind of instant access to this massive amount of computer data, sensory telemetry is what it effectively is, so that we can help large organizations fight very advanced tactics.
Very cool.
Nation-state level threats.
So what you just described sounds kind of like a graph.
It is exactly a graph, and it's a graph with time series components.
You just had to say the word graph, didn't you?
I like graphs. Graphs are fun, man. Graphs are cool.
I do not like graphs. I cannot lie.
Yeah. Well, as soon as you started describing kind of like the path that thing was going, I was like, wait, hold on a minute here. There's pathfinding, multiple like levels of traversal.
Vertex direction. It's a graph.
Yeah, and we, when we were building it, we talked a little bit about this at last year's summit. We actually tried things like Neo4j and we tried Titan, and we actually thought about doing it as like sharded MySQL, right, with kind of the relational joins there. And we realized that all these different things that we kept trying to do, except for Titan, we're basically rebuilding Cassandra. So we were looking at sharding Neo4j and sharding MySQL and sharding all these other non-clustered databases. And we eventually came back to just building it in Cassandra and building kind of a Titan-like graph API on top of Cassandra.
Mm-hmm.
This is something I rail against often is in 2016, the not invented here on a database. I think it's kind of outmoded anymore. But you can move on to other problems. There are plenty other interesting problems to solve. And when I hear an organization building a database technology in this day and age, it doesn't make a whole lot of sense. If you don't put your thoughts and efforts behind something like Cassandra, pick another open source database. There's plenty of them out there. Inventing a new one is just ridiculous. You're wasting your time, and you're definitely not spending your money properly.
Yeah, there is, and that it's actually kind of funny because that's one of the talks. That's one of the things that Luke and I give a intro talk a lot, and we kind of try and explain Cassandra from the point of view of people that have made relational work at like large scale. And eventually what you realize is you're effectively treating a relational database as a key value store and managing all this garbage on top of it. And that Cassandra kind of just does it for you. And that's, I just think that's it's one of those things that people don't really realize how much work is involved, because Facebook built out MySQL at scale, and then that's the references. Well, Facebook did it. It's like, well, they've also invested like, millions of dollars in making MySQL scale with like lots of people. So
Facebook does it, and YouTube does it, and Tumblr does it. But like, your company probably isn't Google or Facebook.
Yeah.
Just because they can do it doesn't mean it was cheap.
I would go back to the point that when Facebook started, there was no other technology, and so they are now, and they've said this before, they're mired in technical debt when it comes to this, their sharding technology that they've gotten. I think somebody senior there at Structure one year was like, it's like a death of 1,000 cuts. It's like the worst kind of thing they can deal with, because that's a high interest credit card they're never going to pay off.
Yep.
You can't just shift infrastructure when 1 billion people are on there.
Yeah, it gets a little hard to migrate trillions of records to some other system. They're just like,
ETL sucks on a terabyte. How about 100 petabytes?
Yeah.
No thanks.
Yeah, that's just terrible.
And coming back, choosing something open source lets you, go in and fix things that you have and work with the community. We found that people like weather.com and New Relic and some other people using time window compaction, and they seem to like it. There's a user that's using it at 5 million rates a second, which is even higher than what we use it at. And had either of us chosen a commercial DB, that wouldn't have been an option. Had we invented something ourselves?
Yep. And this is actually comes back to what we were talking about before with DocuSandra. Like, they released it because that's not how they're making their money. Like, you put a time window, you wrote your own compaction strategy, you put it out there, and I remember when we talked about this a little while ago, you've been getting pull requests and you've been getting enhancements from other people, and that's just really cool. That's amazing.
Well, and Pearson could have very easily just tried to build the entire thing from the ground up. Right? They could have said, we're going to build a whole new document database. And Thanks. The world needed that. But instead, what they did is they just layered on top of something that was already established. They don't have to worry about the distribution layer.
Yep.
You know, there's a bunch of people worrying about that all the time, and they can fix bugs as they come up and deal with that, and they can deal with the top layer, and that's another interesting way to think about open sources is ecosystem.
Mm-hmm. Yeah, I think it's very, very smart. So, okay, cool. So I think we hit all the topics that we wanted to touch on. Jeff, really appreciate you coming on and talking about CrowdStrike and what you guys are doing. And I didn't even realize we'd be talking about graph databases. But we touched on Graph, Cassandra. We may have even mentioned MySQL, Mongo, sharding, Insanity. So I think we hit a lot of things. So Jeff, is there anything you wanted to talk about before we sign off here? I think you may be hiring.
Yeah, we have openings in all sorts of departments. So everything from my infrastructure team, we've got security openings, we've got dev openings, we've got just about anything interesting at the company has openings in it. So if you're interested in CrowdStrike, we've definitely got some openings.
Cool. Awesome. All right. Well, thanks again, Jeff.
I understand you're hiring 500 people a minute. Is that the thing?
Yeah.
Something like that. Yeah.
Yeah. He's hiring. They're hiring people, and it's effectively a time series problem where you need time window compaction to track it.
That's a lot of people. Good luck.
Cool. Awesome. Well, thanks a lot, and see you next week.